I am super excited to go over the information that we're about to discuss with you. We're going to talk about how to find the area of a triangle, and I'm going to start out with generating or making the area formula of a triangle from a parallelogram so that we see why the area formula works the way it does. And then we're going to apply that area of a triangle formula to two problems right here. Let's jump into it. So we see that we have a normal parallelogram, and we've seen in earlier videos that the area of a parallelogram is the base of the parallelogram times the height. So area equals B or B times H, or base times height. Okay, so the area equals the base times the height. Now, let's think about this. If I have any parallelogram, I can make a triangle out of that parallelogram, meaning I could shape this parallelogram any way I wanted to make all kinds of different triangles. So I could make a parallelogram out of this triangle and out of this one just by adding another triangle onto it. What do I mean by that? Let me show you. I could cut this parallelogram into two triangles. And so that means that the area of one of those triangles, if we take a look at it, with height h and base b, would be how much of the area of the parallelogram? Well, we took half of the total parallelogram to get the triangle, so the area of that triangle would be half the base times the height. So the area would be equal to 1/2 of the area of the parallelogram, or half the base times the height. And that's your formula for the area of a triangle. What I mean by you can make a parallelogram out of any triangle is, we could take this triangle right here and just kind of lay it and flip it around right on top of itself so we have two equal parts, and now you have a parallelogram. You find the area of the parallelogram and you divide it by 2. Isn't that cool? I think it's so awesome. So you don't have to actually make a parallelogram out of each triangle every time. Now that you have the understanding, you can use that formula for the area of a triangle. So in a triangle, we always need to look for the base and the height, which are the same as the base and height in a parallelogram, in that they must be perpendicular to each other or make right angles. So the base of a triangle can be any of the three sides of a triangle. The height always has to be the perpendicular distance from a vertex that is what's called opposite the base. So it's like you're looking down from that vertex out onto the side that is opposite it. So the vertex that's opposite the base is going to be the part of the vertex that doesn't touch that base. So this vertex touches this side and that side, not that one. So 12 is the base. You see that 12 is perpendicular to 6, so we find the area. The area is going to be equal to 1/2 the base times the height. So I'll put a little b here and a little h there, and that is our formula. Well, the base again is the side of the triangle 12 right there, and then the height is going to be 6. Now there's a couple different ways you could simplify this. We could certainly do 12 times 6 and then divide by 2, or we could do half of 12 and then multiply that by 6. So I'll do that. Half of 12, or 1/2 times 12, is 6 times 6, which is 36 meters squared. So I want to point out also, some people like doing it this way. Some people would do it 12 times 6 and then divide that amount by 2, which is the cutting of that parallelogram into halves. That would also give you 36 meters squared. So you have that commutative property that you could rearrange the order in which you multiply these things as well. So let's say 6 divided by 2 works really nicely and 12 doesn't. You could do the 6 divided by 2 first, is 3 times 12. So there's certainly flexibility with how you do your calculations. So that's one example of area of a triangle. I included a second one just to show you that we could have a height that is not necessarily outside the triangle, but one that is inside the triangle. You could also have a height that is part of the triangle. So here we have the height is 7 meters. I've thrown in two bases here. We need to choose which base is the one that goes with that altitude, another word for height, of 7 meters. Well, let's start with our area formula. I like to get our basics down. 1/2 the base times the height, or B times H, as we said before. Now, the height, we already know, is equal to 7 meters. Now I'm going to look for the base that is perpendicular or makes a right angle to the 7. Here it is right here. So you've got the 14 makes a right angle to the 7, and therefore the base that we care about that's perpendicular to the 7 is 14, which means that 10 is extra information that we do not need. So the area is equal to 1/2. I'm going to put those open parentheses representing the base and the height, and then we're going to insert our information into our formula. So we have 1/2 times the base is 14, the height is going to be 7, and notice here I have one number that does not divide nicely by 2 and another number that does. Let's say the 14 was over here and the 7 was here, we would move the numbers so that we could multiply 1/2 by 14. So, half of 14 is 7, times that 7 there, and that's going to be equal to 49. Remember, we're finding area, so our units are square units, which in this case are meters. Super cool stuff. And you might be looking at that 10 saying, how do I know that that 10 isn't a base? Well, we don't have a height coming from this base to that vertex like that. So the 7 meters, which came from that vertex to the base opposite it, was the one that clued us in that 14 was the base. There you have it all, a nice look at how to find the area of a triangle, why the formula works, and a little bit about the relationship between the heights and bases of triangles. Go rock some area problems of triangles.